In this video, we're going to use properties of logarithms to write each of these expressions as a single log, or as the logarithm of a single quantity. So let's go ahead and just review properties of logarithms here. And you can read through those, pause the video. And the ones we're going to use in this particular video, this property here, the logarithm of a product to some base a, or any base, can be written as a sum of the logarithms. And keep in mind that this goes both ways. So if you have the sum of logs and they have the same base, you can write it as log of a product of those quantities, in this case m and n. Same thing with the next one. We have the log of a fraction. You can write it as a difference of the log of the numerator minus the log of the denominator to the respective base. And back the other way. If you have a difference, you can write it as the log of the fraction of that m, in this case n, m over n. We'll also use the next one here, the log of some number m to the power r to base a, can be written as the exponent can be brought as a coefficient over here, r log of m to base a. And we've used the change of base formula in solving logarithmic equations. So let's go to the main problems here. So for the first one, we have the sum of two logs, and we want it as a single expression. So to use the properties that I just went over, we want the coefficients to be either 1 or a negative 1, depending on which one you're using. So this is a coefficient. One of the properties tells me I can bring this over as an exponent. So this is still going to be base 3, and this will be x cubed, and the 2 now becomes the power of this expression. Same thing with the next one. Have a coefficient of 5. This 5 can become an exponent for this variable y. So this becomes the log, the base 3 of y to the 5th. And of course this one here will be power to a power. Here will be x to the 6. And then once you have it as a sum of logs, you can write that as a single log. So this becomes the log. Remember, they have to have the same base. You can't do this if this is base 3 and this is over here base 2. So again, x to the 3rd taken to the 2nd power, that becomes x to the 6. Multiply the exponents. We're going to have y to the 5th. So once we have the sum, it becomes the log of the product of those two. So this becomes x to the 6 times y to the 5th. And put parentheses just to make sure that it's clear that it's the log to base 3 of this entire product. Okay, and the next one, got the log of x plus 1 minus 1/2 log of x minus the log of x squared minus 1. Notice I don't have a base on this one, but this is understood to be base 10. If you don't have a base there, that's always base 10. So what's going to happen here is this 1/2 is going to come over here. Now I could read that as negative 1/2 and bring this and make this a negative 1/2, but I don't want to deal with negative exponents here, so I'm going to leave the minus there. The 1/2 comes over here, and then the coefficient here is 1. This end will be a coefficient of minus 1. That'll be okay. Minus 1 here. So this becomes then the log. This is be just a minus 1 or just a minus there. Brought the 1/2 over. So I have the log of x plus 1 minus the log of x to the 1/2. So there, that goes to the denominator as you saw over here. Here it's a plus, so it's a product. If this had been a minus right here for the first one, then I would have the y to the 5th in the denominator. So this becomes then, in the numerator I'm going to have x plus 1, because I have a minus here. That goes to the denominator. Instead of x to the 1/2, I'm just going to write the square root of x here. Then here I have another minus, so that tells me I divide here. That goes to the denominator, so this will be x squared minus 1. And it's the log of this whole thing here. And then I can simplify it. At x squared minus 1, that's going to be x minus 1 and x plus 1. And mark this out here. X squared minus 1 then is replaced by x minus 1 and x plus 1. And then I get a factor of x plus 1 in the numerator and 1 in the denominator. So those divide out. So this is equal to the log to base 10 with parentheses or brackets here. So in the numerator the x plus 1 cancels, so that just gives me a 1. In the denominator then I'll have the square root of x times x minus 1. And there we have it as a single log of this expression. So we'll leave that as the answer. Thanks for watching. We'll see you next time.